This is a great place value game called target drop. And so this is great for those students who may be able to recognize which number's bigger when they're making and modeling them out of proportionate resources like our MAB. But when they're just given two numbers like this and you ask them what's bigger, 195 or 212, they might say that 190 is bigger because it's got a 9 in it. And so that's what target drop aims to teach, because here on my target you can see I've got hundreds, tens and ones, and on my target I'm going to drop a bunch of equally sized counters, and where it lands, its place when it falls down is going to determine its value. So students will put those counters in a cup, they'll shake it up, and then they'll drop it onto their target. And then once it's been dropped on their target, they need to organize it and just make sure that anyone that's kind of on the line, we move it to which area it had more of the counter left over in. So here I can say I've got 2, 4, 6 landed on one landed outside my target altogether, and I can see that I've got 4, 5, 3 and 3, so 6 tens and 100. And then once I've done that, I'd write down the number I've created based on the place my counters have landed. I've got 166. Then my partner would have their turn. So they've got 464. Now, when I started teaching this, I used to just say, whoever's got the biggest number wins a point. They keep playing and whoever wins the most points at the end wins. But then next thing you know, instead of the students just nicely dropping their counters on, they want to win. So they're being all dodgy about it and might just try and tip them all out on the hundreds just like that. And so it makes for a pretty messy game. So to avoid this, what I do is I grab a dice and on 3 sides I write S for the smallest number and B for the biggest. Then at the end of the round, one of the students will roll the dice. If it lands on a B, the person with the biggest number gets a point, and if it lands on S, the person with the smallest number gets a point. So that just stops when they're trying to tip their counters on them trying to either optimize to get the smallest or biggest, because at the end of the day it's going to come down to chance who gets the point. Now if you want to, you can also make game boards that go into the thousands, or you could even drop the 100 and just have a board with tens and ones. It's even fun at the beginning of the lesson to make some bigger circles, whether you've got hula hoops or even some masking tape, and throw some bean bags with those quantities to make some initial numbers. But I'd also still recommend having some MAB blocks on hand, because if students are still struggling to tell which one's bigger or larger, it's still a great idea to go back to our resources that are proportionate to the value and get them to make those two numbers side by side so they can see for themselves which one is bigger.